Hello students! In our previous video, we learned about prisms. We saw they have many shapes. But usually, we majorly use triangular prism for study purpose. This angle is the prism angle denoted by A. This angle determines the amount of bending that will happen to the light when it passes through it. The angle is formed by two lateral faces. These two lateral faces are from where the light enters the prism and from where the light goes out after refraction. We saw that when a laser beam is made to fall on the surface at an angle, it bends inside the prism, and when it comes out, it once again bends at the second interface, thus called as refraction of light through prism. But we asked you, how do we find out how much light is bending? To answer this question, we need to repeat the activity but slightly different way. So let us do an experiment to understand the refraction of light caused by prism. For that, let us do the same activity but differently. Fix a sheet of white paper on drawing board using drawing pins. Place a glass prism on it in such a way that it rests on its triangular base. Trace the outline of the prism using a pencil. Name its vertices A, B and C like this. Draw a straight line inclined to one of the refracting surfaces AB. Now fix two pins at points P and Q on this line as shown. Let us call this line PQ now. Look for the images of these pins which are at P and Q through the prism on the other face of it, that is on AC side. And fix two more pins at points R and S. But wait, you don't have to fix these pins R and S randomly. Fix them such that the pins at R and S and the images of the pins P and Q, which you can see through this AC surface, they all lie on the same straight line, just the way you can see on your screen. Next, remove the pins and the glass prism and complete the figure like this. So you'll get a new figure. Name this point as E, where the line PQ meets the edge of the surface of the prism. Similarly, join and produce the points R and S till the edge AC of the prism. Let these lines meet the boundary of the prism at F. Now join E and F. Draw perpendiculars to the refracting surfaces AB and AC respectively and name them NN' and MM' on AB and AC. This is the light ray, just like a laser beam, which was falling on the surface of the prism. It is called an incident ray. The angle formed by incident ray with this perpendicular, we all know, is nothing but angle of incidence. That is angle I. Now you already know that when light enters from rarer medium into denser medium, it bends towards the normal. So just like we saw in the glass slab, when light enters the glass slab at an angle, it bends towards the normal like this. So here also, ray PQ will bend towards the normal and travel inside the prism straight. Just as it reaches point F, observe that it again travels from denser medium to the rarer medium, which is the air outside. So it will bend like this again, but this time it is opposite to the previous. This time light bends away from the normal. So now RS becomes the refracted ray or an emergent ray for the surface AC. This ray forms this angle with the normal MM' and it is called as angle of emergence, that is angle E. So then what is the angle of refraction here? Yes, it is this. Mark these angles, that is, angle of incidence I, the angle of refraction R, and the angle of emergence on the sheet. Now wait, what if we want to know by what angle the ray of light has bent while it comes out from the prism? Let's see. See the incident ray. If the prism was not here, the ray would have traveled in this direction. Because of the prism, the ray has deviated from its path like this. So you can clearly see that incident ray travels in upward direction, while emergent ray is traveling in the downward direction. So now if this emergent ray is extrapolated back, we see that both incident ray and emergent ray intersect here at this point. This is the angle of deviation, which means that light has deviated or bent as much as this value of the angle while passing from the prism from its original path. Isn't it? Yes. Thus, the angle formed at the intersection point of the extended incident ray and the extended back emergent ray is called the angle of deviation. It is represented by the Greek alphabet delta or D. Now compare the refraction of light through prism and the slab. Is the kind of bending that occurs in prism the same as that in glass slab? Pause the video, think about it, and we will see you in the next video.